Hello class, welcome to Geometry Lesson 6.3, which is all about properties of parallelograms. By the end of this lesson, you should be able to use the properties of parallel lines, diagonals, and triangles to investigate parallelograms. So let's first explore the opposite sides of parallelograms and how they're related. So if we're talking about a parallelogram, that means that we have two sets of parallel sides. So AB would be parallel to CD, and then BC would be parallel to AD, and those would be my two sets of parallel sides. Okay? Now, those sets of parallel sides, so the two purple sides and the two blue-green sides, those are congruent. So purple is congruent to purple, blue-green is congruent to blue-green. So every single time, parallelograms have opposite sides that are congruent and parallel. Then, if I were to draw a transversal or a diagonal going across this shape, then if you think about it, I have parallel lines, and drawing the diagonal is like drawing a transversal. So then angle 1 is congruent to angle 4, and angle 2 would be congruent to angle 3. If you drew that diagonal in, you would also be splitting the parallelogram into two triangles, and those two triangles would be congruent because, as we just said, we'd have an angle that was congruent, and then we would have this side, because of the reflexive property, and then we would have another angle. So it'd be those two triangles, ABD and triangle CDB, would be congruent by angle, side, angle. Now my question for you is, with that information that I just shared with you, and we have parallelogram WXYZ, what is the measure of YZ? Good luck. Hopefully you looked at YZ and said, okay, YZ on this parallelogram is opposite from side XW, therefore YZ has to be the same length because they are congruent. So YZ is 3.27 units. Theorem 6.7 talks about how the opposite sides of parallelograms are congruent. So if you want to take a screenshot of that, go ahead. And now let's talk about using the opposite sides of a parallelogram. So if I give you this quadrilateral and I say that it is a parallelogram, so PQRS, and then I have sides, PQ is 4x. I think it's a little clearer on your screen than it is mine. And then QR is 7x minus 3, RS is 5x minus 3, and SP is 2x plus 12. And I want to find the value of x. There are two different ways that I can do that. Since I have two sets of opposite sides, I could say 4x equals 5x minus 3, and then solve for x there. Or I can say 7x minus 3 equals 2x plus 12, and solve from there. So if I do the second one, the purple sides, and I say 7x minus 3 equals 2x plus 12. If I add 3 to both sides and subtract 2x from both sides, I'm left with 5x equals 15. Divide both sides by 5, and I have x equals 3. So now, if I have, that didn't work. If I have what x equals, I can solve for each length for the sides. Now, be smart about this, because if it's a parallelogram, that means you only have to solve for two sides because you only have two different measures on a parallelogram. So if I plug 3 in for QP, I have 4 times 3. That means that this side is going to be 12. That means this side has to be 12. If I wanted to check my work, I could say 5 times 3 is 15. 15 minus 3 is 12. Okay, that worked. But you wouldn't have to. And then we have the purple sides. We could do 7 times 3 is 21. 21 minus 3 is 18. And if I wanted to, I could check my work by plugging it into the last side. 2 times 3 is 6. 6 plus 12 is 18. Okay, so those are the lengths of each of the sides of the parallelogram. Now, question 2, I will let you solve. Good luck. Hopefully for this one, you started labeling your parallelogram and you said, okay, if the fence along Chaco Road is twice as long as the fence along Grover Lane, I'm going to use X to represent my variable for Grover Lane, since we don't know how long it is. So Grover Lane becomes X, Chaco Road would be twice that amount, so 2X. And then if I remember that opposite sides of parallelograms are congruent, that means Village Drive also has to be 2X because it's opposite of Chaco Road. And then Jones Road would have to be X because it's opposite Grover Lane. Then I know that the fence around, that's perimeter, right? That means I'm going to add up all 4 sides and set them equal to 600 meters. So I have 2x plus 2x plus x equals 600. Or maybe you counted them up right away and you said, that's 6x. And you went right to the step where 6x equals 600. That's fine too. Then divide both sides by 6 and you have x equals 100 meters. I just said meters really weird, sorry. But then the question was, what is the length of the fence along Jones Road? If I look, Jones is represented by X, and since X is 100 meters, I know Jones Road is 100 meters. Example 3. Okay, explore angle measures in parallelograms. How are consecutive angles in a parallelogram related? So remember, consecutive means in a row. So if I look at this purple angle, my consecutive angle would be either of these blue angles. This other purple angle would be opposite because they're not touching, they're not in a row. If I go from left to right, my consecutive would go that way. If I went from top to bottom, my consecutive would go that way. They're both considered consecutive. Now the cool thing about consecutive angles is that they are always, always, always supplementary. And remember, supplementary means that they equal 180 degrees. So that's going to help you solve problems. The reason they're supplementary is if you think back to, I think that was chapter 2 when we did dance transversal. And remember we had consecutive interior, or we called it same side interior. Those are the same things. And if you think about it, here's my parallel lines, or here's one set, and here could be my transversal. These 2 angles are consecutive interior. Okay? So consecutive interior, they were the only ones that were not congruent that we talked about at that time of the year. All right, then let's talk about how opposite angles of a parallelogram are related. Now the opposite angles, so like the purple and the purple, or the blue and the blue, those are always going to be congruent. So you can use that information to help you solve problems as well. So if they're right next to each other, they're consecutive, they are supplementary. If they are opposite from each other, they are congruent. So why don't you use that information to explore angle measures in this parallelogram and figure out what is the measure of angle C. Good luck. All right, hopefully you noticed that angle C was consecutive with angle D. They're right next to each other. So then you said, okay, they're consecutive. That means they're supplementary. So I can say 180 minus 114. That leaves me with 66 degrees for the angle C. Here is one of the theorems talking about how the consecutive angles are supplementary. So if you want a screenshot of that to remember that information, go for it. And then theorem 6.9 talks about how opposite angles are congruent. So if you want a screenshot of that, go ahead as well. All right, now let's use the angles of a parallelogram. If in this picture, I know the green shape in the fabric design is a parallelogram, what is the measure of angle 2 or the measure of angle 2 is twice the measure of angle 1. And then I want to solve for what is the measure of angle 1, angle 2, and angle 3. If I look at this picture, I don't have any information on what any of those angle measures are. So angle 1, I'm going to say is x, because I don't know. But I know that angle 2 is 2 times greater than angle 1. And then since angle 3 is opposite angle 2, I can say that that is also 2x if I want. Then I have a couple ways I can solve this. I can either use the information I learned back in 6-1, where we said, okay, a four-sided figure has 360 degrees, and I can say if I add up all of these angles, the one opposite of angle 1 would also be x. I would have 1, 2, 3, 4, 5, 6 x's, and I could say that it equals 360 degrees, and I could solve for x by dividing by 6. Or you could say, okay, angle 1 and angle 2 are consecutive interior angles. So I could say 1x plus 2x is 3x, and that equals 180 degrees. Divide both sides by 3, and you get x to equal 60. So both of those methods work. However you saw, like when you were thinking about how we were going to solve this problem, use it. Like, they are both acceptable ways to solve the problem. But I am not done yet. I want to label angle 1 equals x, so I know angle 1 is 60 degrees. Angle 2 is 2 times the measure of angle 1, so I know angle 2 is 120 degrees, and angle 3 is opposite of angle 2, or supplementary to angle 1. So I know it has to be 120 degrees as well. All right. Question 4. What is the value of A? Good luck. Hopefully for this one you saw that angle H and angle G were consecutive interior angles. Therefore, they are supplementary. So I can say A plus 5 plus 8A minus 5 equals 180. And if I combine like terms A plus 8A gives me 9A, and 5 minus 5 is 0. So then whole numbers, the constants go away. So I have 9A equals 180. Divide both sides by 9, and you're left with A equals 20. If you have questions, please be sure to reach out for some help. And Theorem 610. This is the last bit of new information for this section. If we have a parallelogram, the last thing you need to know about them is the fact that if we have two diagonals going through the parallelogram, they cut each other in half. So that means that WA is congruent to YA, and then XA would be congruent to ZA. Okay, so that information gets used to solve problems about diagonals within parallelograms. So it's really important to know the diagonals bisect or cut each other in half. With that information, I want you to see, can you solve this problem on your own? If we have this parallelogram and we know that SU equals 35, what is the measure of SK? Good luck. Hopefully you said if SU is 35, SK is half of that diagonal because it is bisected. That means that 35 divided by 2 leaves me with 17.5. So SK equals 17.5 units. And the very last thing is our concept summary. So here is everything that we've talked about in this lesson. If you have questions about anything that I've said, please be sure to reach out for some help, and I'd be more than happy to assist you. Have a great day.